In this video, I'm going to show you how to build your first multi-tier C++ application using our DataSnap technology. There's lots of information online and in the DocWiki about building DataSnap applications. Here's a page that's in the DocWiki that gives you an overview. It allows you to build multi-tier applications, a server side that might connect to a database, a client side that'll connect to the DataSnap server, call some methods, pass some data. And there's lots of tutorials about creating your servers and creating your clients, as well as connecting to a JavaScript client application and to mobile client applications. But in this first video, we're just going to keep things simple and build a DataSnap server in C++ BilderXE3 and a simple DataSnap client that calls some methods of the DataSnap server. To that, we say File, New, Other, C++ Builder Projects, DataSnap Server. And there's three different DataSnap server wizards available. There's the DataSnap REST application, which will build a DataSnap server that supports the REST protocol running on your Windows server. And you can have web pages and you can use client applications to make REST calls into your server. There's a DataSnap server wizard, which generates a server application using the DataSnap technology, regardless of the protocol. And at this point, you can choose TCP or HTTP. REST is always using HTTP protocol. And then you can also build on top of our web broker technology so that you can combine the web broker and DataSnap technologies together to have a web server-side application that has DataSnap capabilities. Let's just start in this video with a very simple DataSnap server. And we can choose three different types of servers. We could also build one from scratch by dragging and dropping DataSnap components. But I want to show you the wizard and then show you what the base DataSnap server components are. So we can build a VCL form application for our server side to give it a little bit user interface. Usually DataSnap servers run in a server. There's no user interface. You have clients that might monitor them. But in this case, we'll just put a little form up. We could also have a console application, so it just runs. And it could be a service application that is installed on the server and is running it as a service. But let's just, for visual sake, put a VCL form application in C++. You can then choose what protocols you want to support. And DataSnap supports TCP, HTTP, and HTTPS. Let's just keep this video simple, and we'll use TCP IP protocol. There's authentication and authorization that's supported in the DataSnap technology, where you can specify role-based authorization for which clients can call methods, which clients can call administrative interfaces into your DataSnap server. There's checkboxes here for generating some sample methods that you can use, and we're going to do that so we can see what happens at the function call level across a multi-tier application. You can filter the data that's sent back and forth. The data and metadata is sent in JSON packets. So you can filter those, encrypt them, compress them. There are also custom filters that you can build yourself to do other operations on the data packets being sent between a DataSnap client and a DataSnap server. If you're going to build some kind of web client, you can generate JavaScript files to give you the interfaces for dealing with method calls, passing JSON packets back and forth. And also, if you're going to build some mobile clients, you can use our mobile connector technology to connect a mobile client to your DataSnap server. Again, we're going to just build a Windows client and a Windows server. Or we could build a Macintosh client and a Windows server. The DataSnap server technology runs on Windows currently. Let's just keep it simple again and do TCP. It lets us select a port. Let's see if there's a port available. The default is port 211. Or you can click this button to find an open port. You can also change it in code and change it in the object inspector. And then we have three choices here for the server methods ancestor class. So if we're just going to do method calls, we'll use T-component. If we want to do database operations, we can use a data module. If we want a full server module with full life cycle support, then we would choose the DataSnap server module. Let's just keep it simple here and have a component class. Now we've got our VCL form, and so let's put in here C++ Builder DataSnap server, and let's save this out, and here's my main form. There's also a server container unit, which has the components, and there's the server methods unit for those sample server methods that are generated. And this is going to be my CPP DataSnap server app. So what do we have? We have a form, in this case a VCL form. We have a server methods unit, which has those two sample methods, echo string and reverse string, that the wizard generated for us. And we have a server container unit, which contains the three components that make up a DataSnap server. There's the DataSnap server itself, and whether it has a property auto start. It also has a couple events like on connect, on disconnect. You might want to count the number of clients that are connected to your DataSnap server and do some logging, keep track of errors, things of that kind. Here's the server class. The server class includes the lifecycle property. The lifecycle can be invocation, which means make a call from a client to a server, do the operation, and it's done with the connection. There's session, which means as a client is connected to your DataSnap server, then keep the connection open until the client closes. And then there's server side, which says the server will keep track of all the session and state information that's available. Let's just leave it as session so as our client is there. And then we have the transport. And the transport, in this case, is TCP/IP. It's using port 211. There's some other operations, keep alive interval, where some keep alive packets will be sent out by your DataSnap server to a connected client to see if it's there. Maybe it gets busy doing some operations on the client side, so it doesn't want to shut it down. You can set up buffer sizes. You can set up pools of threads, because a thread for each client that connects to the DataSnap server will get started, and you can set up a maximum number of threads if you want. So those are the three files that get generated out of the wizard besides the project itself. In here, we could also add additional methods in our DataSnap server. We'll just use these two standard ones. We could go and look at the header code and just right in here in the public area, define additional functions and their interfaces and their return values and any parameters, and then compile those in and do the implementation, and they'll be there to be used by your clients. We'll put a panel on the user interface so we have something there. So we'll save it and we'll run it. Now, first thing, if you've got Windows Firewall turned on, you'll see this message come up because your DataSnap server is trying to access port 211. It tells you the name of the application that's trying to get control, and you can choose to allow access. And now my DataSnap server is running. So let's go over into the project manager project group. Let's add a new project. This is going to be a C++ builder FireMonkey desktop application. It'll be an HD application, and this is going to be my C++ builder XE3 DataSnap client application. And we're going to put an edit box, and we'll put a label, and we'll put two buttons for the two methods that we want to test in our DataSnap server. And the first one is going to execute the echo function that's over here in our server method. And the second one is going to exercise the reverse in our server method over here to reverse a string. Now, DataSnap is built on top of the database connection technology that we have, so we need to put down a T-SQL connection. We can go over to our Data Explorer, and under DataSnap, we can add a new connection. Let's call this our DataSnap test connection. Here it asks us what protocols we want to use. I'm just going to use TCP and that port 211. The name I'm going to, from my client to my server, is going to be localhost. It's all running right here. I can test the connection, and the connection succeeded because the DataSnap server is running down here on Windows. We're not doing any special logging in, so we can again connect and disconnect to it. And let's put a checkbox, and we'll give it the label for DataSnap server connection. And then on its on change event, we'll just say SQL connection 1 connected is equal to the checkbox is checked. Now, if I was going to run this on a Macintosh, I'd have to have the host name or IP address where my DataSnap server was running. We could always go over to our parameters and change localhost, or have code that starts up and chooses the right host where my DataSnap server may be load from an INI file. And if we just save all of this, let's go back to our demo area and create a CPP DataSnap client. Here's our main form, and this is our CPP DataSnap client app. In order to get information about those interfaces from the DataSnap server, I select the SQL connection component, right mouse click, and you'll see a pop-up menu called Generate DataSnap Client Classes. So we'll generate this, and what gets generated is source code, which is the interface methods that is going to execute the commands to call the remote method. And then we pass any parameters, in this case a Unicode string, and we'll get the result back from calling the function for both echo string and reverse string. And if we can't connect to the DataSnap server, then it'll throw exceptions that we can handle. So we need to save this generated source code file, and we'll put it in the client, and this is going to be our DataSnap client classes. You can give it whatever name you want. We need to include the header file so that we can call those methods. So in here, we'll just say include datasnap client.h. So once we've added the include file for those generated client class interfaces, we can now create event handlers for our two buttons to call those remote methods. So for Echo, we'll put some code in. And what we're going to do is say tservermethods1client. That's the name of the class that was generated for us. tservermethods1 client is that name. We can go and look at the header file, and here it is, tservermethods1 client. And it's got some command operations. It's got our remote methods. And again, if we change and add methods on the server side, we'll need to regenerate the datasnap client classes again, and they'll show up over here. Then we'll instantiate a connection by calling new tservermethods1 client, and we'll pass it SQL connections dbx connection command to make the connection. And then inside of a try block, we'll call via temp the remote method, which is actually calling into this server method interface echo string, passing the string, which is the parameter, running these commands, executing the command remotely, and then getting the result back. And we put an underbar finally of the try block to delete that instance variable temp of the connection to the server method. And we can do the same thing for the second button that's going to call reverse string. Let's just copy this source code and paste. In this case, we're going to call reverse string. And we'll save all this. Let's do a make to make sure everything is okay in the code. It is. Let's run the client. And we've got the server running underneath here. Here it is. So let's put in some text. Hello, world. And then notice that label 1, which is our enter some code, is getting echoed back from the server, and calling reverse string will set that label to the reverse of whatever's in the code. And if we call and are not connected, and it says connection cannot be nil, make sure the connection's been open. Right, so that's that built-in code for testing to make sure that everything is good. When you try to call a remote method, you need to be connected. And we can do all of this in 64-bit Windows for the server side and do a build. And so now we have a 64-bit version. Let's allow access. It's running. If we look in the task manager, we've got our CPP datasnap server. It doesn't have the star32, so it's running as a 64-bit process. We go back to the client, leave it at 32-bit, and run it. And let's connect to the datasnap server and call echo and call reverse. A 32-bit client, because it's running in its own process, talking to a 64-bit datasnap server. So there's your first C++ builder datasnap client and server.